MassMotion version 5 is the latest release of pedestrian simulation software from Oasis. We have introduced several new features that will improve the overall simulation experience for our users. The most significant new features are listed here and allow the user to improve and control the simulation and to describe the agent's behavior in even more detail. Improvements have been made to the agent dynamics and the self-organizing behavior of these agents, and also for the situation of bi-directional flow around corners. These features now offer a better representation of real-life situations and refine MassMotion's natural wayfinding ability. Let's take a look at how these features impact the simulation in MassMotion 5. In the first example, we will look at self-organizing behavior. The example at the top is MassMotion 5, and below this we have the previous version, just to show the difference that can be achieved. The agents make their way from open space to a narrow aperture, and we naturally see some queuing around this. Notice the difference in shape in the new version. This now more closely represents observed results in this type of situation. We can observe in the bottom simulation that the agents collapse into a semicircle around the opening, but the new feature allows for more orderly queuing. It is interesting to note that no real change to the flow rate is observed. Next, we look at bi-directional flow around corners. The channeling behavior of agents is a very interesting and complex problem. And in this example, we can see that the green and orange agents maintain good channeling around the corner. The agents now have a corner detection capability, and a repulsion force is introduced into the agent at this time. This simulation is set up so the agents give way on the left shoulder. However, this can be changed to allow for cultural differences and for the way people would act in this situation around the world. These new features add to the power of MassMotion 5 and are very important for streamlining the behavior of agents and making them act in a more realistic manner.